Okay. Today we'll discuss on the Kubernetes. Okay. So Kubernetes is a container orchestration platform where it will manage like hundred and thousands of containers for the management and scheduling purpose. We'll use Kubernetes. So apart from Kubernetes, Docker also developed one tool, that is Docker Compose, and the Docker Compose has some features to manage multiple containers, but it is not flexible as this Kubernetes. Okay. And there is one more tool also available with Docker, that is Docker Swarm. With the Docker Swarm also you can able to manage multiple container instances, but again it has some drawbacks when compared to the Kubernetes. So Kubernetes will support multi-container orchestration, and it will first of all, it will integrate with any cloud. Okay, that is a major advantage. So Kubernetes will integrate with cloud tools. Let's say I want to use Azure Disk. Okay, you can use Azure Disk for your container storage. That is possible with Kubernetes, and you can use the cloud resources as well. I want to use Azure Gateway, I can use it. Load balancer, if you want to use, you can use it. And disk we have used. If you want to use storage account also, you can use. So all things are integrated with Kubernetes easily and compared to the other container orchestration tools. The other one is Docker Compose and Docker Swarm. Some people still use Docker Swarm for the simple architectures like 1 to 10 containers. They will use Docker Swarm and Docker Compose also. So Docker Compose is like a multi-container platform, okay, where you can use to run like 2 to 5 containers in one file. Okay, so this is again a separate tool provided by Docker. This is also separate tool provided by Docker. So Kubernetes is an open source one. It is open source. Hmm.
So if you have some two content, after how you can run.
Your voice is breaking. Tell me.
If you have two containers, how can you run in Docker?
You have 2 containers you want to run, right?
Yeah. In
In
Docker,
Docker.
I want two containers.
And containers you can use Docker Compose. Okay.
But images, right? Docker images. I will say the Docker compose.
Your voice is does not have any clarity. I'm unable to understand you.
Images, right? Not containers, right?
Docker?
In the Docker compose, we can declare the Docker images first.
The Docker Compose only will define images and you will define services. Okay. How to connect those 2 containers? You will define services. Okay.
Yeah, so I will connect. I am driving. I will in the end. I will actually.
This is not part of in scope as of now. Okay. That is a different
Okay.
concept again.
Okay.
Okay. So Kubernetes, coming to Kubernetes, it is a open source and it is widely used by multiple organizations and it is in highly in demand also. And with Kubernetes, there is no restriction to handle thousands of containers and so much traffic you can handle through Kubernetes. So example is Hotstar only. So with Hotstar, you can see millions of users will be able to connect and stream the cricket live. So that is possible through Kubernetes only. Kubernetes have some replication pod feature is there. With that replication pods, it will generate so many pods according to the traffic. Okay. As traffic increases, it will increase the pods. So to install Kubernetes, so we can do via Minikube. So Minikube is a uh, small software where you can run in your local system and simulate Kubernetes setup. Okay. And you can also install in the Docker desktop. In the Docker desktop, there is a button you can directly go and enable so that it will install Kubernetes and you can interact with Kubernetes. For that, you need to have this Kubernetes extension in place. And there is one more website, play with K8s. So play with K8s, same like Docker play with Docker, same like Kubernetes also play with K8s, where mm, in the browser you can try to run Kubernetes pods, etc. And when it comes to the cloud, Azure will provide AKS service to run Kubernetes architectures. In the AWS also they have some other service. They will use that to run your Kubernetes workloads. Okay. So first we will see installation in Docker desktop. Okay. So Minikube also you can try. For the Minikube, just go to Google and type Minikube. And it based on the your OS, let's say Windows, download the package. Here instructions are there to install it via PowerShell as well. Okay. And to start your cluster, just start Minikube start. Okay. And if you want to see how the parts are running and these commands you need to. So this is like a small cluster they will deploy in your local and they will utilize it. And for it, at least you need to have 2 GB memory and 2 CPU. So if you install in your local, it may affect your memory and your laptop may be slow. So try to install in a virtual machine these things. And for the Docker, mm, so for the Docker, go to settings and click on Kubernetes on the left side. So here you will see one button to enable Kubernetes. So which will download Kubernetes related pods and it will you can interact with the Kubernetes. Okay, so this one also enable in a server only. So if you have larger CPU and high memory, then you can do it in your local machine. Otherwise, create a one server and deploy there. So we will directly deploy it in Kubernetes. So I will create one Kubernetes cluster. For that, go to AKS Kubernetes services and create a Kubernetes cluster. choose a resource group, and here cluster preset configuration I'm doing for the test purpose. So I will use dev test, and then in the cluster name I will call it as AKS01. Choose a region and then availability zone, pricing tier, then Kubernetes version. So the latest version is 1283. Default is 127.7. So I'll go with the default one. Then automatic upgrade. So keep the default option. So authentication method. You can also authenticate with AD as well. For now, we'll go with local accounts. Then next, so inside Kubernetes, it is asking for one agent pool. Okay. So I think before this, we'll explore the architecture. Then you will understand what is this node pool and all. Let me go back and open architecture. So coming to the Kubernetes architecture, you will see one control plane. Okay. And you will see node plane, worker node 2. So this will be called as control plane, and bottom section will be called as node plane. So inside control plane, you will have these components: etcd, control manager, scheduler, and API server. So these are the main components inside your Kubernetes cluster control plane. So API server will interact with the kubectl. Okay. So kubectl is a command line tool where you can run commands to interact with the control plane. So the command will connect it to API server inside control plane, and it will communicate with other resources. Okay. So here etcd is a key value store where it will store all the information related to the pods. Okay, pods, all the information inside Kubernetes will store in etcd only. It is like a database, but it is a key value store. So next is control manager. So control manager will control the states of the clusters. Okay. Whether pod is running or starting, if it is stopped, it will start it. So those things it will be managed by control manager. So next, scheduler. So scheduler will schedule pods in the worker nodes. So this will check which worker node is empty, and based on the resource allocation, it will schedule one pod to one worker node. Okay, so these are the main components inside your control plane. And next, coming to the worker nodes. So worker nodes are like a virtual machines where you can deploy your pods. Okay. So in Kubernetes, pod is a smallest object deployable in Kubernetes. In the pod, you will see containers. Okay. The containers are encapsulated by the pods. And in one pod, you can run one container or multiple containers based on the requirement. Okay. So in the worker node, the main components are kubeproxy, kubelet, container runtime, and the pods. So here, container runtime means it is like a Docker engine or some other tools like Cryo or Podman. So these will be used to run the Docker container engine on top of the worker node to run the pods. And then kubeproxy. Kubeproxy will be utilized for the networking purpose inside pods. How to manage networking and all will be taken care by the kubeproxy. Then kubelet. So kubelet is an agent that will install whenever you add one extra worker node, and it will take the instructions from the control plane and deploy pods. And this kubelet will give the instructions to the inside worker node to create pods, replica sets, etc. So this is a main architecture coming to the Kubernetes. And in the cloud Kubernetes, you will see one extra component over here for the Kubernetes AKS, that is Cloud Control Manager. So with the Cloud Control Manager, you can interact with cloud resources like Azure Storage, Azure Gateway, Azure Load Balancer. Okay. So those things can be interacted by Azure Cloud Control Manager. And in the bottom, I have mentioned container registry. So whenever any image you are deploying, let's say example Nginx, that will be stored in a one container registry. Either it is a Docker hub or it is your own private ACR container registry. So from that, it will be deployed to the pods. Yeah, we will create one Kubernetes cluster now. So this agent pool is nothing but the worker node, which here we have explained. So here I am taking only one worker node and named it as agent pool. So by default, it will come with agent pool name. If you are deploying with the command line, you can name it with a different name, or you can add a different node pool also, and you can name the different name also. So right now we'll go with the default one, and here it is showing it can hold around maximum 110 pods. Okay, and it is based on the Ubuntu OS. So next, choose the default option and go to next. And here in the container networking, it is asking to use either kubenet or Azure CNI. If I use kubenet, it will use the internal IPs of that Kubernetes. If I use Azure CNI, it will interact with the Azure related network. So we'll use Azure CNI and DNS name automatically it will come. Network policy also I will choose Azure. And next, if I go back previous step, so whenever you deploy one load Kubernetes cluster, automatically one load balancer will be created. So that is a standard load balancer. So which will be used for routing traffic to this cluster. This is a default option. Next, so if you want to attach any container registry, you can attach here. So we will attach this previous ACR. If you don't select also, after creation also you can select. Next, policy not required. We'll move on to next. Next, monitoring not required. Next. So whenever I create, it is creating one infrastructure group as well with MC DevOps, Docker KTS, AKS 01 Central India. So I can keep the default option. And in the top, you can see enable secret store CSA driver. So this one you can enable to interact with the key vaults. If some key vault is holding some secrets, then you can enable this option so that we can integrate that key vault with this cluster. So for now you can disable, but this option is for the key vault integration. Next, next, and create. So there is one website we are talking, right? To browser play with K8s. You can type. New site is part that helps to get answers. Okay. Looks like it is changed. Kubernetes for beginners. Mm. So here they are giving some instructions how to start the Kubernetes cluster and then how to apply. So this is somewhat complex actually. Previously it is easy, same like a Docker, play with Docker, but they are adding some extra commands to run. So if you want to try, you can try this one as well. In the browser, you can try Kubernetes. Otherwise, you can create one cluster. So meanwhile, so to interact with our Kubernetes cluster, mm, we need to install one extension in Visual Studio Code. So I will open my VM. So I'm in the VM now and will open Visual Studio Code. And under extensions, I will install Kubernetes extension. The first one you can select and install, which is from Microsoft. So this will install all the required tools to interact with the Kubernetes cluster. And with this, we can also some YAML files easily to deploy into Kubernetes also. So now it is installed. Now go to the Now our cluster is deployed AKS 01 and it is running. So to connect with our cluster, you can click on this button, connect. It will show how to connect to this cluster. So we need to run these commands in our VM. So let's go to VM. Say here, first I need to install AZ tools. AZ is there or not? So AZ tools are not there. I will quickly install. So now AG tools Azure CLI is installed. Now I will open a new terminal and type AZ. Let me open command AZ. AZ tools are installed. We will restart this Visual Studio Code. Here in the terminal, type AZ again. So AG we are able to interact. So now copy the commands. First to log in with your account using AZ login command. Okay. And then after login, you can close this window. And in the solution, in the command window also, you can see what are all the subscription we have. Then you can copy paste this command. Then you can copy the next command, which will download the credentials of the cluster. And enter. So now whenever I downloaded, it downloaded to users dot cube dot config. So in this place, it copied the credentials of my Kubernetes cluster. So let's go to the file, open file, need to go to C users, Azure user and dot cube and config, open. So here you can see we have, let me one cluster here under the clusters, and it is named as AKS01, and it downloaded the certificate data. So through this certificate information, we are able to connect. We can connect to the AKS cluster. So let's close this. And if I go to Kubernetes icon, I can see AKS01 is coming already here due to the connection which we have downloaded. Okay. So it is reading that file dot cube slash config file. It is reading and automatically it is authenticated. So inside it, we can see all the different pods, nodes, etc. Okay. So we will create one pod, okay, and deploy. So to create pods, there are two ways. So one is imperative way and one is declarative way. Okay. So in the Kubernetes, you will have these main objects, pods, replica sets, and deployments, services. And you can create these objects using either imperative way or declarative. Imperative way means I can run one command in command line, same like Docker run. I can create one pod, or you can create a YAML file and deploy from YAML prime file as well. So the YAML file is called declarative way, and imperative way command line is called as imperative. So now we will try to create with the imperative way. Let's go to VM and open terminal. And I will say kubectl run nginx and image equal to nginx. Enter. So this will create one pod. In the message we can see pod nginx created with image nginx, and if and expand workloads and pods, I can see nginx pod is up and running. So this is a graphical user interface we are getting through this extension. We can directly see. If I want to see through command line, you can run kubectl get pods. So this way you can see what are all the pods running inside this cluster. So if I see what are all the actions happened inside while creating this nginx pod, you can run kubectl describe pod space what is a pod name nginx, enter. So this will show what are all the events happened to create this nginx pod. So it is created under name nginx namespace default service account default when it is started. What are the labels? What is the IP it is provided? It is an internal IP it is provided. And what is a container ID? Okay, it is using Docker engine, so it is showing that same. And current state is running and any restart count is there, it will show here, and then where it is mounted, and then conditions and volumes, and in the bottom we can see some events. So first thing, it is assigned this agent pool. Okay, here the agent pool name is agent pool 325 VMSS. Okay, so whenever you deploy Kubernetes cluster in the Azure, it will be a VM scale set. Okay, if I go to Azure VM scale sets, virtual machine scale sets, here you will see our nodes. Okay, here two instances are created for this AKS agent pool, and here we will see this size. The size, okay, in the size we are seeing a VM size. In the overview, we can see 2 out of 2. 2 out of 2 D4 D5 V5 instances are created for this node pool. Under instances, we can see the instance details. Two instances are running VMSS0 and VMSS1. So these are the worker nodes for the Kubernetes cluster. So from these two worker nodes, it is chosen. It chosen 00 node. Okay. So this 00 node it has chosen, and then it pulled the image Nginx from the Docker Hub, and then it pulled this image in 5.57 seconds. Then it created a container Nginx, and it started the container Nginx. Okay. So this way you can see what are all the things happened in the background when we are created a pod Nginx using describe command. So to check the logs of this container, you can type kubectl logs pod nginx. I think pod is not required. Directly you can type kubectl logs nginx. So it will show what are all the logs it is generated inside that pod. So it started some worker process and it is using some Debian image inside it. Okay. So this logs command will be used for the troubleshooting. And whatever we run inside this command line, you can also run using extension as well. So right click on the pod and you will see this describe command. So it will show the same things inside a window. So you can see neatly with this extension instead of command line. And you can describe logs as well. So you will see some options. Choose the default and click on run. So it will show the logs for that running container and it will be updated over time. And this extension has some other visible as well. You can directly attach this Nginx container and you can run command inside of that Nginx container as using this debug. Okay. This requires open folder. We are getting some issue, but to run to connect to your container, you can use same exec command. Same like Docker exec, you can use kubectl exec -it, then nginx